All right. Thank you, Dima. And thank you, 42 London, for having me presenting this workshop. My name is Rongxin. I'm a preceptor in computer science at CS50 Lab at Harvard, where I'm mostly responsible for creating course material and software development. So today I'm gonna give you a sneak peek overview of how we build the CS50 Duck and how we utilize AI in learning, and in particular in computer science education. So for those of you who might not heard of CS50, just a quick introduction to what CS50 is. So CS50 itself is an introduction to computer science course on campus at Harvard. It is one of those largest intro course at Harvard as well. And this picture actually depicts what it looked like to sit in the lecture. It is at the Sanders Theater. We record our lecture in the fall semester, and then usually we will publish them right away, and everyone can see it through YouTube and different kinds of channels. And the course was taught by Professor David Malin. He is a great educator. And we also have the course, published on different kinds of open courseware platform, for example, edX. And just to give you a sense of the scale of the course, on campus, on average, we have about 600 Harvard undergrads taking the course every year in the fall semester in particular. We also have about 200 students taking the course at Yale University because the course is actually offered at Yale. And interestingly, earlier this fall semester, we also offer the course now at Oxford University through their continuing education initiative. On edX, we have accumulated about 6 million learners so far across the globe. So that's the scale that CS50 is operating. Now, back to the main topic of the workshop. The reason why we see AI could be useful in education is actually because of the problem we are facing right now. When ChatGPT first came out last year, people think that ChatGPT is too helpful, and almost all the educator in the education sector is like kind of push away the idea of using AI in education because they quickly think that students might be able to get answers, solution directly from these generative AI tool, which is bad for education, right? So ChatGPT itself is too helpful. And however, we think that if we put pedagogical guardrails around this kind of AI technology, we can actually make use of it and actually utilize AI to, have a positive impact on the education in general. So, like many other schools, when AI first came out, we have a course policy. We updated our course policy by saying it is not reasonable to use any kinds of AI-based software, like commercial-based AI software, for example, ChatGPT, GitHub Copilot, Bing Check, and whatever tool that might be able to generate a solution to a problem set. We basically tell students do not use it. It's against the course honesty rules. However, we also updated our course policy that it is reasonable to use all the AI tools we built for the course. For example, CS50 Duck is one of those software we built for the course to use. And if students using our AI tool to complete a problem set, that's totally fine. If somehow the student get a solution from our AI tool, that's also fine. But that's clearly our fault, so we should fix that as well. So why we call this the CS50 Duck? So this is all rooted from the rubber duck debugging technique. And I actually have a duck with me as well. And I understand that most of you also have a rubber duck in some sort with you as well. So rubber duck debugging is basically a technique where programmer, during programming, when they stuck out some bug, they usually will talk to someone else, go through the code line by line, trying to see where they did wrong. But sometimes it's not always the case. You can find someone else next to you and explain the code. So you might find an object to talk with it, right? So usually it could be a rubber duck. It could be like a pen or eraser or something. So yeah, so we find this idea pretty interesting, and actually in the on-campus lecture, we will actually give students a actual rubber duck for them to take home and to use it. However, as you are aware, we have a large online audience as well, like student. We cannot afford to send them a rubber duck. So actually, we implemented a virtual rubber duck into our CS50 IDE. So as a VS Code extension. So in our CS50 IDE VS Code extension, student can actually do rubber ducking as well. So they go to this VS Code extension. They will often ask the duck the question or whatever bug they are trying to debug. For example, here in the slide, the student type, I'm hoping you can help me solve a problem. And this CS50 Duck Debugger that we built is really powerful. It would be able to instantly message back the student with just quack often. Sometimes quack, 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 right? So student will just keep talking with the duck until the student realize their mistake and move on with their code and their assignment. And we find this very effective. And in fact, this might look funny, but multiple students write like thank you letter to us, thanking that this to change their learning. So we are so glad to hear that. But with generative AI, we saw this is actually a good entry point for us to experiment or to test. What if we, pipe generative AI into education? And this CS50 Duck Debugger seems to be a good candidate for us to try that. So in one night, right, we secretly update the VS Code extension to connect to our AI backend. And when students trying to talk to the duck was actually able to respond to them in plain text English, in like a human-like, generated human-like response to the student. And this is actually the real response that generated by AI if student asking this question. So we essentially now brought the duck to life by powering the duck with the generative AI technology. And the motivation behind there's two main motivation behind why we are doing this. First, we see that with AI, we can essentially provide students with virtual office hour 24/7, not just for the on-campus student, but for all the students taking CS50 or whoever trying to use our online IDE, they will be able to get assistance from our duck for free as well. And also, we were able to achieve the 1-to-1 teacher-to-student ratio because even at Harvard, for 600 on-campus students, we will hire about 60 to 80 teaching assistants to try to bring down the teacher-to-student ratio. But we can nearly get to 1.1 for sure on campus. We also understand that the world is not perfect, right? So some area might not have the resources to actually bring down the teacher to student ratio. Oftentimes it is one teacher again to like 50, 60 students. So with AI, you can essentially have a teacher or expert next to them, tutoring them. So we really see this a valuable opportunity to use AI to achieve this 1-to-1 teacher to student ratio. Now, to give you a broad technical architect view of our system, how we build this CS50 Duck and what are the main components. So in this diagram, you will see there's 4 components to our CS50 Duck. On the left side, which is the end user, and on the center is the CS50.ai. CS50.ai itself is a AI server, what we call, that power all the AI tools we build. And underneath the hood, we are actually using the OpenAI models. And in particular, it was the OpenAI model that hosted on the Azure Compute Cloud by Microsoft. And to give you a quick introduction to what's the CS50 IDE. So for all the CS50 students, we provide them with a standardized online IDE called CS50.dev. It itself, it's essentially a VS Code running in the cloud, powered by Codespaces. Codespaces is one of the managed service by GitHub. They invented Codespaces. So we adopt their technology. We customize the container, we customize the IDE so that everyone taking CS50 will have the same IDE with all the software package pre-installed, so that they don't have to worry about installing any software when taking CS50. And we believe that by providing like a standardized IDE to a student, we essentially lower the hurdle, lower the bar for students to take the course. It is often the case that when you try to learn a new programming language, the time you spend on configuring your local environment already discouraging, and sometimes it might scare away lots of people. So that's why we have this Visual Studio Code for CS50. And this is actually the perfect place for us to experiment AI technology through the CS50 IDE. Before we roll out the CS50 Duck, we actually did tiny small experiment on how we can actually use the ChatGPT, not ChatGPT, like GPT-4, essentially. So we initially actually made a lightweight VS Code extension called explain highlighted lines of code. So in CS50 IDE, when students writing their code, they will be writing in a so-called text editor. And this extension essentially will be able to explain code to the student in human language. So student can just highlight the line they want to get an explanation, and then they can just right-click and click explain highlighted code, and they will get like a human-like explanation on what this code is actually doing. So this is our first experiment to try out GPT on how GPT can actually help learning. Because you can imagine without this particular extension, if student was stuck with their code, they would need to go ask someone else, go ask the online community, or post somewhere for a human to help them. So with this extension, they can just get the explanation right away there. And also because we control the prompt, the explanation would not be overly complicated, because oftentimes GPT would be so helpful that would give explanation that might be uncomprehensible by beginner. So this tool is particular built with that awareness, right? And so after that, we also built a few other extensions. For example, we built another extension called Style50. In fact, it is not building a new extension. We essentially revamp our tool. Historically, we have a tool called Style50 that when students run Style50 on their code, it would generate a formatted code that we think that the student should follow. So here's what I mean. Consider this code. If you look at this code, this is actually a C code. Everything is left aligned, which is not great, although the code would compile fine, but it wasn't a code in good formatting. So we built an extension, right? Style50. When Style50 get executed, it will present a div editor view, essentially like showing the student, hey, this, on the left is your code, on the right is the properly formatted code that we think you should follow. So student can actually, change their code on the left to match the code on the right as to fix their code. But sometimes this view could be confusing, overwhelming as well. Like student might not understand, okay, what do you mean by these green spaces or this highlight? What does that mean? So by using generative AI, we will be able to ask GPT to explain what the changes the student need to make to achieve a good formatted code. So the student can just click explain changes, and they will get a human-like explanation as well through the duck. As you can see, that we also incrementally build all this extension around our CS50 duck to further expand the capability of the duck. The duck now not only able to chat with the student, but also able to help student with the code formatting and the design even, which I will talk next. On campus, we also have a online discussion forum that we use called Ed. So students can actually post a question in the forum, and then usually a teaching assistant will reply, or other student can chime in and reply as well. We also integrated AI into that platform. So now whenever student posts a question on the Ed discussion forum, the duck will actually quickly follow up with the response. And oftentimes the duck did a pretty good job in answering the question by not giving out solution, but giving out like a general guidance and an answer to a question. And if you look at this particular question, the student already understand what they are doing. They were asking for improvement and how they could improve their code. If you pay attention to the last line, the student was asking, is there a more efficient way to write this code? So again, we see that GPT-4 was able to notice the nuance in that question and generate a pretty good response, in our opinion. We actually endorse it as well. But also, when we introduce generative AI into all this communication pipeline, we often have a disclaimer as well. At the end of the day, right, the AI could make this mistake as well. So if you, as a student, you use whatever AI generated response in your assignment, you are actually responsible for all the mistakes you make. So we often have a disclaimer saying, hey, this is an AI generated response. So if there's something wrong with it, you should be aware. Don't take it for granted and don't trust it in fullness. And also, this discussion platform actually has a feature called endorse. So previously, if a human or student answer a question that actually is quite good, the teaching assistant will actually endorse that question saying, hey, for future related question, this answer is good enough. You can just look at this answer. However, since this is an AI and no longer human, we use this tool as a way to tell students, you know what, this answer or response generated by the AI is also being endorsed by human, meaning a teaching assistant or instructor look at the response and think the response is correct. Therefore, we endorse the question as a way to introduce the concept of human in the loop, because we don't want to throw AI into everything and then call it a day. But the AI could behave incorrectly sometimes. So we are still, as a human, still look at all the AI generated response before it get posted to the public. CS50.ai itself, if you go to this address now, you don't have to be a student in CS50. If you visit this address now, you can actually get redirected to a landing page that looks like ChatGPT essentially, but with pedagogical guardrail I mentioned earlier. So in this CS50.ai chat view, you can ask whatever question you want. Of course, it has to be related to CS50 or computer science in general. For example, let's say I have a issue with my code, right? I don't know what's going on. I can go ask CS50.ai, and CS50.ai will use the CS50 duck will usually give you some suggestion or hint on why you are making that mistake and what you can try to fix your code. If you post this code to ChatGPT, you might essentially get a complete solution back. So that's the difference there. And you also notice that we gamify this a little bit by putting little yellow hearts next to the duck. This is a way we try to throttle usage because we at the early phase of development, we noticed some student would chat with the duck 300 times a day. We think it's too much because in the real world, when you ask a TA, I don't think you can chat with the TA 300 times per day. So we try to simulate it, but at the same time we also trying to put downward pressure on students keep abusing the duck. So by putting this throttling mechanism, we basically encourage the student to think critically before asking a question. If the student asks too much question in a short period of time, they will essentially use up their heart. They have to wait 3 minutes to generate a heart as well. So I think it worked quite well. Honestly, it wasn't really help reduce the cost that much on our end, but we think it's a good guardrail as well for students. So now we can take a look at the system prompt of the duck. So why the AI would behave like a duck, right? So there's a thing called system prompt. We essentially we tell GPT-4, hey, you are a friendly and supportive teaching assistant for CS50. You're also a rubber duck. And importantly, right, we want you to answer students' question only about CS50 and the field of computer science. In fact, the AI tool we built was not exclusively only can be used for CS50. There's many other institutes using our duck for their course as well. So we are happy to share our tool with them for free. And importantly, we want the AI to not provide any solution or full answer to the problem set. That's the most top priority why we are building this tool. And whenever the student are chatting with the duck, this system prompt is always enforced. Now, people might ask, okay, what's the one question I get many times from students will ask, okay, what's the difference between your tool and OpenAI ChatGPT? Usually my answer would be, oh, the tool we are building is actually like more stupid than the ChatGPT. And actually that's the whole goal. We are trying to make ChatGPT more silly here, less helpful, but in a good way. And because of these two are built by us and student and by course policy, we student can only use our tool for generated. Sorry, by course policy, right? Student can all the generative AI tool the student can use is the tool that built by us. So we essentially control how the AI should behave and respond. So it's often kind of fun that on April Fool's Day last year, we tweak the system prompt a little bit, right? Saying, hey, you are a supported teaching assistant for CS50. You are also a rubber duck in Rick Astley span. We rickroll lots of people in the course, but that's just our tradition. So we slightly tweak this system prompt, and his lyric "Never Gonna Give You Up" it's quite popular. So we also instructed that, hey, you know what? Also cheer up the student by the end to always mention this line of the lyric and answer the question. So on April Fool's Day, when students ask a question, they will still get a pretty helpful response, but somehow the duck was so encouraging, keep saying, hey, you should never get up, something like that. And it works quite well as well. And we are surprised by how powerful the AI can behave like that. But anyway, that's just a fun twist when deploying AI into the wild. So let's see the results, right? After deploying AI into CS50. So far, because the tool is freely available to use. So far, we have about 200K users. We have processed about 9 million prompts so far. And on a daily basis, there are about 35,000 prompts, meaning question or queries that get processed every day. And this is the survey result from the on-campus student at Harvard and Yale last year's fall. So I would say students use our tool pretty frequently. About 75% people use the tool frequently, and 94% find the tool helpful. And here are just some real comment by our student. One student said that they felt like having a personal tutor, and they love how the AI bots will answer questions without ego and without judgment, and generally entertaining even the stupidest question without treating them like they are stupid. And importantly, it has as one could expect, inhuman level of patience, because no matter how many times you ask the duck, that will always be cheerful and answering the question without any annoyance to you. The other student also mentioned that the AI tool gave them enough hints to try on their own and can help them decipher errors and possible errors that they might encounter. Some students also appreciate that we or some other school, right, they build their own version of AI, because some students think that ChatGPT would just be so distracted for learning, at least for beginner. That I agree, because I think for professional working in the industry, right, AI could also be helpful. And ChatGPT, GitHub Copilot, those two are certainly good for productivity, but that's based on the assumption that you already master, the concept. You know what's going on here. That's why you can just quickly take whatever AI generated response and do some tweak and then apply it to your work. But that's not the case when you are new to programming or learning any topics, right? You just need to think through yourself rather than taking answer and rather than just moving answer around and submit it. That basically has nothing. There's no positive impact on your learning whatsoever. Now with that, I will just walk you through how we actually implement the ducks using OpenAI's API. I will just explain this at a very high level. That could be helpful for your hackathon project, I believe. And actually, you don't have to follow everything I said in this slide. There's no hands-on programming happening in this workshop as well. But if you want to look at the code that I mentioned and some other implementation detail, you can look at this particular repo. So previously, I briefly mentioned the overall architecture of the CS50.ai, of CS50 Duck. And here are the main components. And here is a detailed view of what's happening. I'm just going to walk you through what's happening here. The moment you type a query to CS50 Duck, it actually sends to our CS50.ai server we built running on AWS. Although all our AI services are powered by OpenAI, we are not just naively just pass on students' query to OpenAI. So we do lots of string processing essentially before passing the query to OpenAI. So first, we would do a PII anonymization. We remove all the identifiable information in the query, because sometimes when user interacting AI, they put their personal information in the query. They put whatever in the query, and because we don't want to violate that, privacy protecting students' privacy is also a top priority. So we essentially scan the query and remove or redact all the personal identifiable information. We also perform a prompt injection detection, attack detection before sending to OpenAI, because at the early phase of development, we noticed some user will use a jailbreak prompt in their query and try to turn the duck into a general ChatGPT, which they succeed of doing that. It's quite fun. So we implement that safe Gara as well. So we do all that, and of course, we will have our own wrapper prompt as well. Our system prompt and our user prompt appended to student's query, and then we will basically send OpenAI a giant prompt to generate a response back to our student. You also notice that there's a thing called VectorDB on top, and there's a rack pipeline, which I will explain later as well. That's essentially a way we try to ground the AI model, because AI model could hallucinate a response, and it's quite often the case that the AI would generate false information, and the rack technique will basically mitigate that. And here are the APIs that CS50 we have been experimenting and used in CS50 Duck. So let's just recap, right? Large language model, why they can do such amazing thing. And so large language model, it's basically a kind of deep learning neural network that would excel in generating content. They can generate audio, they can generate image. But here, in our case, we are focusing on text generation. When you talk to the CS50 Duck, you are actually not talking to the duck, right? When you're interacting with AI, the AI is not actually talking to you like a human, but they are actually generating response that somehow seem to respond to whatever you just said to them. There's no difference in CS50 Duck. CS50 Duck is essentially a chatbot, but a chatbot with context. What I mean is understand that you are asking a question related to CS50 or computer science in general. So it knows what you're talking about. So it will be able to respond, generate a response that correlate or aligned to what you send to them. And whenever you are developing a LLM system or AI system, you are essentially dealing with 3 roles. And this is actually true whether you're working with OpenAI's API or working with Anthropic's API. You are essentially dealing with these 3 roles. The system role, often referred to system prompt or system message, is essentially a general guideline to guide the LLM's generation. In CS50 Duck's example, we tell the AI, hey, you are a helpful assistant, you are also a rubber duck. So this is the general guideline that are guiding the LLM generate a response. So basically, when the LLM generate a response, it would try to follow that rule as well. It would try to generate a response in a way that could be somewhat interesting, because the duck is playful. So that's how the LLM can achieve that. User, it's obvious, us, or student, or anyone who send query to the LLM. And LLM often referred to as the assistant, or the AI model often referred to as the assistant. So whatever response you generate, you get from the LLM model, that's considered an assistant response. So again, system message, right? This is the system message, a simplified version of the system message that we have for the duck. And in reality, we have almost like 1,000 characters long system message for the duck. And this is the diagram that basically summarizes a one-turn interaction between the user and the LLM. So you would prompt the LLM to generate a response. That's one interaction. And now the concept prompt engineering, right? To me, this is a fancy word of basically saying string manipulation, or the way of asking question. So when we say prompt engineering, you're essentially playing with the prompt you are sending to the LLM. So in your prompt, you can provide example. For example, you would say, hey, provide example. Basically, you want the AI to generate something that match your example. That's why you provide some example first for the LLM to see, okay, this is the thing you want me to generate in a similar fashion. Okay, I will do that. You can also ask the AI model to adopt a persona, which is the same as what we are doing for the CS50 duck. We ask the AI model to add as a rubber duck. You can do more with prompt engineering to achieve the desired goal for your LLM system. I will share this slide afterward as well, so you don't have to take notes right now. Okay, the API that we use extensively in CS50 Duck is the check completion API. What it does is essentially when the API expects that you provide a input string or an input message, and then the API will just generate a response back to you. That's the whole purpose of this API. It's called check completion. And again, and if you think about it, why it is called check completion, why it is called completion API? Because again, you are not actually chatting with an AI. The AI is just generating text. So you are providing a question. The AI is just complete the question for you, and that's it. So that's why from AI's perspective, they are not actually answering your question. They are completing whatever string you provided to them. And here is what it looks like in Python code. Again, the code is not the important thing to pay attention here. You will notice that in the code, there's a still role being mentioned somehow. That's the system role and the user role, right? System role is the thing I just mentioned earlier. So you are guiding the LLM's text generation. And then you will also need to provide, okay, what user test you are sending me, the API. So you should have some kind of a user message to send to OpenAI. And that's actually where the prompt engineering happens. You don't have to engineer anything. You can just put a simple question there. That's also prompt engineering. Or you can do more sophisticated processing before sending that message to the check completion endpoint as well. You can do, can you help me with my filter preset? Oh, for example, I want you to do this, do this, do this. That's already considered prompt engineering. So you can do that in the user message there. So once you have this, system message and user message ready, you will just call the API and you can get a response back. And that's how you use the check completion API. And this is usually the most basic or classic API that you will be using when you are interacting with OpenAI's model. This is actually similar to Anthropic's model as well. They will have similar API structure, and they will always expect you to send a user message to their API endpoint and get a response. So now you might ask, okay, cool, now I can get a response back. Then how can I facilitate a conversation? So a conversation, again, you are not really converse with an AI model. The AI model is, again, only generating text. So what's actually happening here when you are chatting with the duck? You let's just say I send a message, right? Can you help me with my filter preset? Filter is one of the preset in CS50. The duck will answer you, the AI will answer you, so you have a response back. However, if you want to continue the conversation, how would the AI know you just ask them about filter preset? The LLM model doesn't have any memory. The reason why the LLM was able to carry forward a conversation is because the moment you ask the next question, you are actually passing back its previous generated response as well. So the more you chat with the duck, the more message history you are passing to OpenAI or passing to any AI provider. And usually you have a message array to hold the chat history. And that's how so here, basically I illustrate, that's how you can simulate a conversation. You just keep storing the response and then append your new user message to the message array and then passing this entire message array to the check completion endpoint and generate the next response. So one issue though with working with large language model is hallucination. Sometimes the AI would think, sometimes the AI would generate a response that looks seemingly correct, but in fact it's nonsense. I still remember that 4 weeks ago, about months ago, when I asked OpenAI, hey, it's 9.11 larger than 9.09, and the AI would just say, you know what, that's correct. Actually, sorry, I asked, is 9.11 larger than 9.9? The AI will say, oh, 9.11 is larger than 9.9. And then it will give me a full proof, a very sophisticated proof that why 9.11 is larger than 9.9. That's clearly hallucination. 9.9 is clearly larger than 9.11, in fact, but that's not the case. So one way to mitigate hallucination is called grounding. You want to ground the LLM with some truth, some factual information. And one technique to do grounding is called retrieval augmented generation. It's also called RAG, which is the RAG pipeline I denoted in my previous diagram. Again, I think this is a fancy term. Someone invented this fancy term. To me, it's just like you are handing the AI a cheat sheet, essentially. You are basically, in the prompt, you are supplying the AI with more truthful information to guide its generation, to guide its response generation. So in the CS50 Duck scenario, we also adopted the RAG pipeline. So when student asks a question, we don't directly pass the question and our wrapper prompt to OpenAI, but first we perform a search. We search through our knowledge database to see if we already have some information related to this question, and then we put it in the prompt, and then we send that entire prompt to OpenAI to get a response back. So it goes through the RAG pipeline first, and then we pass the prompt, the updated prompt to OpenAI, to GPT-4 to generate a response. And that's how the RAG pipeline fits into this LM system. But you might wonder, okay, how can you facilitate the search? There's a thing called embedding. So when student asks a question, we also use OpenAI's embedding API services to generate a vector representation of the English, essentially. So this is the vector representation of what is Flux, generated by OpenAI's embedding API. It's a 1,536 dimension like a array. At the same time, we also need to build our knowledge database. So one proxy we can use is lecture caption, because we record our lecture, we also send it for caption, send it for human transcription. So we will get lots of text caption back. So this is actually good for us to use to build a knowledge database. So we can actually build a knowledge database about everything that David said in the lecture, and we can use that as the fact. At least for CS50, we consider that a fact, right? So for all the caption, 2-hour-long lecture, 10 weeks, so it's 20 hours long, lecture material. We chunk each lecture caption into like a 30-second chunk. We also create a vector representation of this caption as well. So that way we have a vector database, another fancy terms that you might heard of. It's essentially a database that storing all this vector representation. So when the time comes, we will just perform an embedding-based search to retrieve the best match document or the best match caption chunks. So here's what's happening. Again, when you ask a question, we quickly create a vector embeddings, an embedding for that question. We perform a cosine similarity or whatever algorithm that the vector database is implemented. We do an embedding search. We retrieve the best match caption. We put that back into the prompt, basically. So if the student only asks what is Flask, we are actually injecting useful information into their prompt. And then we put this updated prompt into our larger wrapper prompt with all the system message, all the guidance, and then we send that entire prompt to OpenAI to generate response. And that's how we enforce the pedagogical guardrails. At the same time, that's how we try to ensure that the response generated by GPT-4 it's more aligned to the CS50 lecture. So that's how the vector database plays a role here. And the vector database we use is Chroma. It's an open source vector database. It's just a database that excels in storing vector data and then good at retrieving vector data when you do an embedding-based search. And this is just another way of illustrating how the RAG pipeline work. So again, the queries comes in, you call OpenAI's embedding API, get back a vector response, perform a search against the vector database, get back the best match and response. You can specify how many documents you want to retrieve, but usually you would want to retrieve the top 3 or top 4, depending on how much cost you want to spend on those query. But after speaking all that, right, those are very low-level implementation on how you would able to build a LLM system or your own GPT. You can also use the GUI or the editor that provided by OpenAI to build your own assistant, essentially, and then use that as well. I'm not going to dive into that much detail there, but you can check that out as well. So here is just a screenshot of me. Go to GPT editor and recreate the duck, basically. But we don't have any control over how the duck behave. But that's just to give you an idea that this is essentially like a SaaS service that you can build your own GPT quickly. So future work, now that we a year after experimenting with the duck, what's the future? We already trying to experiment something further, just to give you an idea, an update on what we've been doing. So this is what it looks like right now. So we, over the summer, this summer, we completely rewrite the entire app, try to make it more responsive and more user-friendly. It works perfectly on mobile as well. But we also explore some of the mode that the duck can provide to students. For example, there's a concept of think, pair, and share. How we can actually make the duck do that, not just play the role of rubber duck debugging. Essentially, how we can make the student more engaged in using these AI-generated tools. So we think that we can actually build a pair programmer. We can turn the duck into a pair programmer through the use of generative AI. So basically, this is what it looks like. So imagine you have a duck pair programmer next to you. So here's a programming task: write a function called check password that checks that a given string password has at least one lowercase letter or something, right? This is the task. Now you are being paired with the duck. So, okay, you ask if the set is correct, and then the duck will respond, yeah, this is a good starting point, because the code I just wrote on the left, I'm trying to write this function, right? So I essentially only type out the implementation, the interface there. And then the duck say, okay, you are doing well, keep going, rather than providing solution again here. And then I implementing something further, and then I ask the duck, hey, do you think I'm on the right track? How do I check uppercase? And then the duck will also give back some suggestion or hints. So that's a way to simulate a pair programming. In CS50, we often also have practice problems, so we can also port that into our pair programming mode. So let's just say here is a separate task that we are doing. We already have sample code, and then the student only need to implement the area where we mark. We leave like a to-do comment for them to finish implementing. But then you can also say, hey, I'm stuck, I don't know how to begin. And then the duck will also give you some like hints or points into where you can start tackling this problem. As if you have a classmate next to you or a TA next to you doing pair programming. Yeah, you can also try, like as a student, right? Instead of asking further assistance or keep going, sometimes you just ask, can you give me the solution? Of course, the duck would not give the solution. That's the whole point of the duck. But the duck will still give helpful guidance in completing that practice problem set. The reason why we are doing this is the practice problems that we provide to students already have solution attached to it as well. But through this pair programming mode, students get more chance or opportunity to actually practice the problem themselves, rather than looking at the question, or rather than looking at the solution and try to think why the solution worked that way. We still believe that the best solution is the one that you came up yourself, even though after lots of struggle. I think that's the most effective learning as well, or at least one of the most effective way to learn. So we essentially turn the traditional, practice problems into like a pair programming style practice problem. This is the duck being essentially the one that are guiding the pair programming. But what if you switch things around? What if the duck is actually the one that need to program, and you are the one to guide the duck program? We think this is also interesting to experiment, because if you master the content well enough, you can also guide a student to complete the code as a way to reinforce your learning. You can keep finding friends to guide them work through a problem, but you can keep guiding an AI, right? You just start a new session and then try again and try again as a way to reinforce your learning. So that's what we've been experimenting as well. So this is what we call the reverse pair programming. So you are now the one that giving guidance to the duck, and we essentially instruct the AI to write faulty or imperfect code that have bugs and error in it, and we want the student to find out the bug or find out the problem or design problem, so that the student will be the one that provide design suggestion and the one to point out, hey, there's some issue with your code. Could you try to solve it? That kind of thing. Yeah. So in this example, right, the duck writes like a lengthy code. So the student would say, here in the demo, say, okay, I think your logic looks correct, but checking through the entire password again for each condition may be redundant. So basically, the student pointed out, hey, Doug, you are not doing too well in your code design. Maybe you should reiterate that. So basically, our hope is with AI pair programming, we can offer better tools for practice and assessment in CS education. Assessment is also something we are thinking deeply as well. Like in the age of generative AI, how you can assess a student well in that sense, because with all this AI assisted tool, whatever assignment the student submits already nearly perfect. Then how can you actually assess their mastery of content? And we think that through pair programming or through this kind of turn-based programming task, if you are able to teach other people or guide other people completing a problem set, then somewhat means you somewhat master the content. So I think there's an opportunity there in assessment using AI as well. So if you want to know more about the technical detail or a more detailed look at how we build CS50 Duck, we actually have a paper that talk about it. It's called Teaching CS50 with AI. And yeah, and that's pretty much it about the CS50 Duck. I would like to thank my team who work on this project. We definitely put lots of effort into building this stuff, and we continue refining it every day, because this tool is also keep evolving every day as well. So anyway, I hope the experiment we did is somewhat helpful. That might be able to inspire you to create different tools to better help the CS education and better put AI into good use. All right, now it's time for Q&A. So feel free to ask questions. I think there's some question in the chat. Let me click that. Right, I think I can go ahead and address the question from the chat first. So there's one from Lucas. What technique do you use to restrict the data not to give the full response? Yeah. So first, we do that through system prompt. In system message, we have lots of rules. Basically, literally say, do this, do not do this, do not do this, do not do this. That's one way we restrict the duck from giving full answer or often too helpful answer. Another technique we use is for the ad discussion forum situation, when student pose a question, we actually have two phases of generating the response. We essentially have the duck generate a response first, but then we also ask the AI again on a separate API call to verify, hey, is this response violate any rules? So basically double check. So we basically calling two API for that. So it sounds expensive. A year ago, it is expensive, but now it seems cheap. Maybe you can afford to do more API call to do something differently. I believe GPT-4o mini is really cheap and powerful. So you can imagine making lots of API call to fulfill one query. Can duck tailor the response to the individual's profile? Okay. Yes, definitely. If you collect enough information about your user, you can definitely pipe that into the prompt. We did not do that. In fact, we try not to do that for some reason. We just don't want OpenAI to know too much about our student. If you use our tool, all we need is a GitHub login Like we use GitHub as a way to authenticate user, but we actually don't know who they are. We don't know their email address. We don't know their first name, last name. We only know their GitHub username. That's all. But in theory, if you are building your own system, you will have students create their profile, type their interest, type their skill they want to improve. You can imagine you can pipe those information into the prompt saying, hey, here's the question. This is the level the student is in. The student is interested in this area. Go generate a response. So it's definitely doable. Samuel asked a question. When you talk about embedding, I see that you use OpenAI. We also seen mention of Voyage AI and ChromaDB. Do they all give similar format of vectors? Similar format could, I'm not sure about Anthropic because I haven't used the embedding services from Anthropic. Format, I think it's similar. It would be like a vector, so it's gotta be some array. The dimension would probably different because even with OpenAI, OpenAI has different embedding model you can choose to use, and different embedding model generated the vector differently. It's just that the model was trained differently. That embedding model was trained differently. So the dimension of the vectors gotta be different as well. Yeah. So better read the doc for sure, just to read their API doc and see what kind of a vector or dimension they are returning. The rule is if you use one embedding model for encoding the user query, you must use that same embedding model to generate the vector for your vector database, because otherwise the embedding search doesn't make sense. Yeah.
Perfect. Thank you. Lucas, please answer your question. You raise a hand.
Yes, thank you. So I had a question about how you restrict the AI, and I understood that you do it via the system prompt, but I also got from the presentation that you do some analysis of the query before you send it to the API, and I wanted to know if there are like known vulnerabilities that you kind of have to check for before you actually send the query to those models in order to not make them behave in a different way. Yes.
I think you are referring to the prompt injection attack detection thing. That's the early days as well. We actually stopped doing that because the AI model now it's clever or good enough to actually immune from those prompt injection attack. But previously, what we did is we literally, so first we have a heuristic to detect if it is a suspicious prompt injection attack, because usually a prompt injection will jailbreak prompt will usually have those weird characters like in the prompt itself. So we actually check those. If we detect there's some weirdness, by regex, it's also very quick and dirty approach. Anyway, once we feel that or we check that, okay, this prompt is suspicious, we just make another API call asking GPT-4 again, hey, do you think this is a prompt injection attack? It's kind of like using black magic to attack, defeat the black magic. Anyway, yeah, that's how we do that. We have a separate API call to ask the AI again, look at this prompt. Is this prompt injection? Just give me an answer, yes or no, and we will proceed. If it's yes, if it is a prompt injection attack, we will just abort that conversation. There's gotta be some false positive scenario, but to protect the system, I think that's fine. But nowadays we no longer do that because the model itself is good enough. And actually, we are using Azure OpenAI. Azure OpenAI on their end, they're also doing this kind of a prompt injection attack detection in the model already, so we don't need to do it anymore. Again, that's why I say the technology keep evolving every day. So some technique sounds reasonable previously, but costs a lot. But nowadays it seems irrelevant. Yeah.
Okay, thank you. Just one more quick question. Is your rubber duck at home now collecting dust, or do you still see use for a non-AI rubber duck?
Oh, you mean my rubber duck collecting? Oh, Yeah, I guess so. I mean the nowadays for me, I don't use the duck that much. Frankly speaking, I use Copilot a lot. So, but from time to time, I will still pick up the duck, to just, I don't know. But yeah, see what you're saying. So Samuel, isn't it expensive running the rubber ducks through OpenAI, especially with all the extra content you provide to each prompt? Oh yeah, it is expensive. That's the answer. So we thank OpenAI and Microsoft for providing support in our work. So they are supporting this work. So that's why we can sustain the compute course. And again, the tool is free. Everyone can use it. But at the same time, the cost is also decreasing or dropping per million tokens. So I don't know, maybe in the future, the cost will no longer be that much of a concern, but energy concern will be another topic, I believe.
Cool. Thank you. I have one more question from myself. I really enjoy the mind map of pipeline you showed us today. I mean the RAG pipeline.
Yeah.
That's I think that's really actual pipeline nowadays for using with the LLM. But if we go just a little bit in details, like next step, how you produce in your team, how you produce actually the RAG pipeline. I mean, when you have some idea, like we want to solve this problem, which maybe short list of, checklist of things, or prepare it like visualization, how it should connect it, like how vector database and in which case it should be connected, actually how you build pipeline. If we go in a little bit more detailed step, like how it looks like when you solve the problem of that.
You mean, you're asking how our thought process looks like when trying to build a RAG pipeline?
Yes. Yeah.
Okay. So first, let's see. So we want to search something, right? So to search something, in fact, the version 0 of the RAG pipeline is essentially we are searching a CSV file. And the reason, because again, the whole problem about RAG, and actually we think about AI, is not about the prompt engineering. We actually think it's how effective your RAG pipeline is. Because we think the LLM is already quite good enough, but it will hallucinate, which is make it useless. If it's hallucinate, it generate false response, it's kind of useless too. So the problem now become information retrieval. So then how you can better search the document you need. That's why the embedding search comes into play, because this machine learning model, the other special type machine learning model that excel in word embedding, right? Translate text word into like an embedding representation. They can produce that when you do the search, it would just able to retrieve the relevant text back to you. And that's actually the thing we need when we perform a search. And it's also an iterative process. Again, I mentioned at the very, very early version of this RAG pipeline on the script that we are writing just to prove the prototype. The prototyping is just a CSV file. But then naturally, you would think searching a CSV is so slow. It takes 5 minutes to initialize that search because you have to load things into the memory. You have to calculate all the embedding or generate all the embedding, and then just to fulfill one query. So naturally, you would think you will want something specialized to do that. Then you will find, okay, there's a thing called VectorDB that can help with that. Then you also gradually know that you shouldn't building your knowledge database on the fly. You should first create a database, right? So you just create a database that has much information as possible that can cover the possible question that would ask by the student. Again, this is still a prototype, right? We only use lecture caption as the source of truth, but we have lecture notes. We have many other things we did not put into the vector database, which we think we should put into the vector database as well. So that when the student asks a question, we can search through different data source and make the RAG pipeline more effective. The people might ask, have you considered multimodal? I think that's another hot topic. Of course, I mean, with GPT-4o, you can feed the model with image and question as well, even with audio. So maybe a RAG pipeline could be you are searching through all the audio file that somehow David said this in a different tone, and then you pipe that into that API call. You can even ground the model generation. I'm just thinking here. We haven't done that, but I think that's doable if we want. But again, it's an iterative process. The whole pipeline you're seeing here essentially only start from one Python script, and then we just gradually build things. It's no longer a Python app. We rewrote that into we're using Next.js to rewrite the app.
Yeah, thank you for answer. Thank you for questions to everyone who asked them. That's really interesting, and I really love the whole vision and how you realize that. Great job. Actually, I'm getting so inspired with that. I see that how it works and what the benefit of that it brings to the people, to the students. That's amazing job. Thank you, Ronxin. Thank you for everyone who come in this stream. Yeah.
Thanks all. Thanks for having me.